Welcome to another exciting video brought to you by Upvision Concepts Academy. We're looking at chemistry, and topic for discussion today is redox reaction. Redox reaction refers to oxidation and reduction reaction. We can define it traditionally by saying that oxidation is the addition of oxygen or removal of hydrogen. So oxidation is the addition of oxygen that's going on in a reaction or the removal of hydrogen. I will give an example in a short while. So this is how we can define it in the traditional way. On the other hand, we can say reduction is the removal of oxygen. Reduction is the removal of oxygen or the addition of hydrogen. So this is how we simply can define it. Example of oxidation reaction is manganese combining with oxygen. So I have 2 molecules of manganese plus oxygen, and I will have manganese oxide like this. Okay, so here manganese is gaining oxygen, so I can put it in bracket. Magnesium is gaining oxygen. All right, magnesium is gaining oxygen. The next example for oxidation reaction can be copper oxide, cuprum oxide plus hydrogen to give me copper and water. Okay, so in this case, copper oxide loses oxygen. Copper oxide loses oxygen. That's for reduction. This is for reduction. So copper oxide loses oxygen. Okay, so we have just tried to define it, the 2 traditional ways of defining oxidation and reduction. Okay, so there's also a modern way of defining oxidation and reduction. We can define this in terms of electron transfer. That is how transfer, that is either there's a loss or there's a gain. So oxidation, in terms of this, oxidation is loss of electron, and reduction is gain of electron. Okay, so this one is very common in our exams, defining oxidation or reduction in terms of electron transfer. So look at the key terms here. Oxidation is loss of electron, and reduction is gain of electron. So we can use the mnemonic WAEC to remember this, where O here is oxidation is loss of electron and reduction is gain of electron. So WAEC mnemonics is helpful for us to define redox reaction in terms of electron transfer. So let me just share with you some examples of oxidation and reduction. Okay, so in terms of electron transfer, I have 2 simple examples here. Okay, so sodium goes into ionization where it loses an electron, and this is oxidation. Why? Because we say it is loss of electron. This electron left, so sodium became positively charged. Okay, on the other hand, chlorine can also gain electron. Okay, chlorine is like this, gain electron to become more electronegative. That is, it will have more electrons. So this is reduction because there is a gain in electron. So we can actually use this to pinpoint what part of the reaction is gaining, or what component or what element is gaining electron or losing electron. We can now term that particular element as being oxidized or being reduced. So a redox reaction is a chemical reaction in which both oxidation and reduction occur simultaneously. So for a redox reaction, oxidation and reduction occur simultaneously. For example, if I have this reaction, I'll write it in ionic form, zinc and copper. So zinc became positively charged and copper became neutral. As the copper ion became neutral. Okay, so from zinc that is stable here to go into a situation where it has more electrons in the atmosphere, it is oxidized. It is oxidized because it gains electron. Remember that mnemonics I shared with you? Oil rig. Oil rig. Most of us want to work in oil companies where you have rigs. You know, you dream of working in oil companies where you have oil rigs. So oil rig is what we use in memorizing redox reaction, where O is oxidation. Oxidation is loss of electron, and reduction is gain. So zinc actually gained electron. Zinc actually lost electron to become this. So it lost electron to become this. It becomes more positively charged. So this zinc loses electrons. So it is oxidized. So as zinc loses electron, it becomes oxidized. And as copper ion gains electron, it gains electron. Already it is having more positive charge, having more protons here. So if you add more electrons to it, it becomes neutral. So it gains electron and becomes reduced. So this is how you can know what component is actually reduced or which component is actually oxidized in a chemical reaction. So we're going to be looking at how to identify oxidizing and reducing agents. So oxidizing agents causes oxidation by accepting electrons, so it is reduced. On the other hand, reducing agent causes reduction by donating electron, and it is oxidized. Example, if I have H2 plus combining with chlorine to give me hydrogen chloride. Understand? Hydrogen here is the reducing agent. Why is it reducing agent? Because it actually accepts electrons. So reducing agent accepts electrons. So it is here like this. It accepts electrons to become this. Understand? So it's a reducing agent. So remember I said in passing that oxidizing agent let me define it again. Oxidizing agent causes oxidation by accepting electrons. So it is reduced. Okay? And the second point, reducing agents causes reduction. How? By donating electrons. It is oxidized. So back to my example. See, hydrogen is a reducing agent because it causes reduction. Hydrogen causes reduction by donating electron. So it donated electron and it is oxidized. So there are two terms now. First of all, it's a reducing agent. Reducing agents are the one that is oxidized, while oxidizing agents are the one that is reduced. So chlorine is oxidizing. Why? Because chlorine accepted electrons and it became, so you know, for this, for you to understand this very well, you can write the ionic format of this. You understand? Hydrogen actually reduced from being hydrogen that is stable to hydrogen that is positively charged. So what happened? For it to become more positively charged, electron was lost. Electron was lost. It's not that it just got missing. It donated it. That's why we call it the donor. So when we say electron was lost, it donated it to what? To this combination, to chlorine. So you see how it is here. It was stable here, element here. When it came in, it became combined, but it's combined. It's having more positive charge. So it's donated electron or lost electron. As a lost electron, it is oxidized. Remember, I said oxidation is loss of electron. So it is oxidized. The state is oxidation. It became oxidized. But anything that is undergoing oxidation is a reducing agent. Why? Because it donates electron. So again, I can look for a mnemonics here. If you say reducing agent, D here stands for donating electron. You understand? So when you see D in this reducing agent, donating electron, just remember that. Yeah, so, but chlorine actually became positive, or became positive by accepting electron. So chlorine is one that accepted electron. All right, so let's go to the next one. So we'll talk about oxidation number or oxidation states. Oxidation number is a theoretical charge an atom would have if electrons were transferred completely. So we have some common rules for oxidation number or states. So our rules, let me just put it as common rules. So number one, I would say that free element is 0. So the number for free element is 0. Free elements, oxidation number is 0, always. Example, e.g., oxygen is a free element. Chlorine, like this, is a free element. So the oxidation number is 0. So for group 1 metals, number 2, group 1 metals. So I have that the oxidation number is +1 from group 1. Example, group 1 metals is sodium and potassium. The oxidation state is +1. For group 2 metals, the oxidation state is +2. Example is magnesium and calcium. So hydrogen is classified differently, but its own is +1, except in a metal hydride. Except in metal hydride. So this is the exception. Except in metal hydrides. That is when hydrogen combines with a metal. So in that state now it becomes -1. When it's combination with a metal hydride, it's -1, but always it's +1. Okay. Then oxygen is -2. Oxygen is -2. Okay. And except when it is with peroxide. Except when it's in peroxide. So in that case, it will become -1 for peroxide. Oxygen becomes -1. So these are the common rules we need to know when we are trying to write out oxidation numbers for elements or compounds. So we'll go into identifying redox reactions using oxidation numbers. So we'll now see where if oxidation number is increasing or reducing, what is happening. Is it that oxidation is occurring or reduction? These are different ways you can be tested. We have defined it as addition or by addition or removal of hydrogen or oxygen. We have also defined it by the transfer of electrons. Understand? So we're also going to be looking at redox reactions using oxidation numbers. Okay, so like I said, we're going to be identifying redox reactions using oxidation number. So in the previous discussion, I told us that oxidation numbers, there are some rules so for oxidation numbers. But if the oxidation number of an element increases, that is in the course of chemical reaction, it is oxidized. And if it reduces in the course of chemical reaction, it is reduced. Understand? So it's a very simple term. Example, if I have this reaction, ion, and combining with chlorine, ions. So I'm combining with chlorine, and I have it that I have ions increased by to 3, and chlorine lost an electron. Sorry, or gain an electron. So chlorine gain an electron here. If chlorine gain electron, this is reduction. Reduction. Chlorine is reduced. And if chlorine is reduced, it is the oxidizing agent. Please always remember this, my oil rig. Oil rig. I know you guys like to go and work in an oil company. This is oil rig. So oxidation is loss of electron, reduction is gain of electron. Now, if a compound or an element is going through reduction process, that compound is an oxidizing agent. And if an element or a compound is going for elements, not compound. If an element is going through oxidation process, that element is a reducing agent. So this guy, chlorine, actually is reducing, going to reduction. Why? Because it gained electron. It gained electron. It was stable here before. For chlorine to become minus, that means minus here, it has gained electrons. Electron is what makes it to be minus. It has gained electron. So chlorine getting electron means that chlorine is reduced or is undergoing reduction, but it itself is an oxidizing agent. And this guy is getting electron. As getting electron, sorry, it's losing electron. Losing electron. This one gain. This one lose. Why is it losing? Why is it losing? Because already it's positively charged here. +2, positively charged. It becomes more positively charged here because more electron, one electron is escaped. Understand? So it lost electron. So this guy is going through oxidation and it is a reducing agent. Now, but let me leave that one and come to this topic. This is what we're discussing now. How do we identify it by oxidation numbers? Now, oxidation number from here increased from 2 to 3. As the oxidation number is increasing, it is being that is oxidized. So, copper increased, copper ion increased from +2 to +3. That is what is increased. Copper oxidation state or oxidation number. Oxidation number increased from +2 to +3. So therefore it is oxidized. It is oxidized. And if it is oxidized, you see the English here, oxidized, it means that this guy is the reducing agent. Understand? Now the next one, chlorine. Chlorine reduced from 0 to -1. Reduced from 0 is so 0 here to -1. You know your number scale now. This 0 is bigger than -1. Don't think because 1 come after 0, then no. This minus, go to your number line. The minus is before 0. So this is reducing from 0 to -1. So that is reduction. So this guy underwent reduction, but at the same time, it's an oxidizing agent. Okay, so I hope you understand the concept of trying to define oxidation reduction or identifying the two kinds of reactions based on the electronic transfer or oxidation number. All right. Okay, so we're going to be balancing redox reaction in acidic or basic medium. So we'll just do some examples, but there are some steps we need to understand. So if we are given some reaction to balance using redox equation notation, the first thing you do is to write the half reactions. Half reactions are actually reactions showing electron loss or gain. Understand? So write the half reactions for the oxidation or reduction. That's the first one you do. Secondly, you now balance the atoms and the charges. Make sure that the atoms and charges are balanced on both sides of the equation. Then thirdly, you combine the reactions. That's, you would have written half reactions first. You combine the reaction and you cancel all electrons. Then you get a balanced form. So we're going to quickly apply this in an example. These 4 steps. Take note of these 4 steps while we look at how to apply them. Okay, so we have this equation on the board in acidic solution. That's what we are told to balance this. So the first thing we do, first of all, this is just an equation that does not show the complete story, but because we know that it's acidic solution, we see that there is this component that combines with something else, and this one combines with something else, and you have, so we're just looking at the key elements in this particular reaction. So we first of all identify which one is doing oxidation and which one is doing reduction. We can look at the oxidation states to know. So we'll write out the half equation or half reaction. Now for the half reaction, I can first of all look at this one. Ion is actually losing electron because the proton here, the positive charge became 3. From 2 it became 3. So let me write the half reactions for this. So I would say for ion, it's actually increased from 2 to 3 because it lost an electron. So this particular thing here is what we call oxidation. Why? Because it lost an electron and it's a reducing agent. Understand? For the other half reaction, this guy this is a radical having manganese and oxygen combined. But this one, negative charge here became positive charge here. It means it gained electron. So I will write the half reaction for this. Manganese 4 oxides. Then I'll look for the electron that it gained. So let me just put the gain here. And you know, because it's an acid solution, there's an element of water being formed. Okay, so hydrogen is also involved. So there's hydrogen involved here. And what we're going to have is this one, which is already here, manganese plus 2, then plus water. I can quickly balance this one by saying that this is 5 here, and this is 8 here. Okay, so it balances out. Okay, I will have 4 here. That's 4 times 2 is 8. So I have 8 hydrogen here. Okay, I have water. Oxygen is 4. So this is what it gained. It gained this electron to become more positively charged. Mind you, oxidation state for this is 7. For oxygen is 7. So by the time you add 5 here, the balance is 2. Okay, so now these are the 2 half reactions. The 2 half reactions for this particular one. So the next thing we'll do is to balance the equation again. Of course, this guy is still not balanced. If this one is 5 here, how will this electron be here? How will it be here? So we're going to multiply this particular ion by 5. Okay, so let's just add everything. I should have 5 here for this to balance. Let's add everything. Or let me just put it here. Let me just put it in the final equation. So this final equation here will now be manganese 4 oxide plus hydrogen will give us, okay, we're adding this. Okay, so look at what we are doing. This and this, this and this, and plus this. So I have iron. Then I have manganese. Manganese is the product, and plus 4H2O. Okay, so so this is basically this is where the missing link is. Okay, so okay, then finally there will be what? There will be iron here, 3, then 5. Okay, so it's balanced now. It's balanced. So I have 8 hydrogen here, and I have 8 hydrogen here. 0, 4 oxygen here, 4 oxygen here. Iron here is 5, iron here is 5. Then this also balances this. I have 1 manganese here, 1 manganese here. So this is how you follow the rules and balance redox reaction in acidic or basic solution. So we're going to be looking at applications of redox reaction. The first application is extraction of metals, e.g. zinc from zinc oxide. So we can extract metals from using redox reaction, to extract metals. Also, electrolysis is another application of redox reaction. We look at electrolysis later. Electrolysis has to do with passing electricity through a solution so that you can either break it down into its components or use what is broken down to do coating. Understand? You have a cathode and anode setup where electricity is passed, and you see that by the time the circuit is completed, you see that the component, the solution where you are passing electricity through is broken down. The elements are broken down and are deposited, are separated into 2. So redox reaction actually occurs in electrolysis. Also, another application of redox reaction is combustion. The third one is combustion. Then the fourth one is respiration and photosynthesis. Then finally, corrosion and rusting. That is how we see redox reaction. So we'll go into tests for oxidizing agent and reducing agent. How do we test for these kinds of agents? Okay, so finally we come to tests for oxidizing and reducing agents. So the first one here is that it turns potassium iodide solution from brown to blue due to the release liberation of iodine. Understand? Number 2, it turns starch solution blue back because iodine starch complex. That is why you have that reaction. Number 2 is reducing agent. So the colorized acidified potassium manganate 7, it turns it from purple to colorless. Potassium manganate 7, it decolorizes it. It turns it from purple to colorless. Okay. Then the final one here says it turns acidified potassium dichloromanganate 4 from orange to green. Potassium dichloromanganate 4, not 4, 6. Potassium dichloromanganate 6. It turns it to dichloramate 6. This is chlorine. This is potassium. Okay, potassium dichloramate 6 from orange to green. All right. So I hope this video has been informative for you. I'd like to thank you for viewing.